Seventh grade math students, we're going to continue looking like we have so far throughout chapter 9. So far, we've been looking at area. Okay, so the other day we looked at finding the area of squares and rectangles, and of course, you take one side times the other side, and that's how you find the area of a square or rectangle. And then we talked about triangles, and of course, you take 1/2 times the base times the height. Okay, and so that's what we've looked at so far. Today we're going to move on ahead, and we're going to look at a couple of different topics here. We're going to learn today how to find the area of a parallelogram and how to find the area of a trapezoid. Students, the lesson number is 9.2. Be sure and put that in your notes, and be sure and put today's date, which is the 12th. Okay, and guys, the reason I tell you to do this really helps your notes to be organized and neat. And I think it's important that you do that. Okay, so if I were you, I would copy down today's heading, I would copy down today's lesson number, and I would put the date in your notes. Okay, now here we go. In order to learn how to find the area of these two quadrilaterals, parallelograms, and trapezoids, we must first learn some things about each shape. Okay, so let's start off with parallelograms first. Okay, so in your notes, I would copy down a parallelogram and then write down some things about this first. Sorry. First of all, guys, a parallelogram always has 4 sides, and that's why it's called a quadrilateral. Guys, any 4-sided shape, it could look like this. It could look really weird, you know. That would not be. It could look something like this. It could be something really weird like that. But if it only has 4 sides, like this shape right here does, 1, 2, 3, 4, this is a quadrilateral. Okay, a quadrilateral is any 4-sided figure or shape. So a parallelogram always has 4 sides. Okay, now it's called a parallelogram because the sides opposite to each other, those 2 sides there, will always be parallel. That means they run the same direction, okay? If you were to extend this side here and make it go on and on forever, and extend this side here and make it go on and on forever, these 2 sides here would never intersect. They would never cross because they are going the same direction. They are parallel, okay? And it also means that these 2 sides are also parallel. Okay, so parallelogram always has 4 sides. Okay, and the opposite sides in a parallelogram will always be parallel. Okay, so just make sure you understand that. Now, there's some more stuff you need to know, so please take some really good notes. For example, the base of a parallelogram can really be any side at all. It doesn't matter. We can call this side here the base, or we can call this side here the base. It doesn't matter, guys. Okay? It does not matter. If the parallelogram is flipped, it doesn't matter. We can call this side here the base, and we can call this side here the base. Okay? So, traditionally, the side that we call the base is the side that the parallelogram is setting on. So in this example here, the parallelogram is setting on this side, so we call this side here the base. Back here, the parallelogram was setting on this side here, or you could say it was the bottom side, and so we call this side here the base. Okay, so the parallelogram, it does not matter which way you turn it or twist it. The bottom side is going to be the base. Okay, now let's talk about the height of a parallelogram. Okay, for example, if we had a parallelogram like this here, and I told you this length here was 6, and this length right here was 18, do you understand the height of the parallelogram would not, it would not be 18. Just like a triangle, guys, remember a triangle like this side here is not the height of a triangle, and this side here is not the height of a triangle. The height of a triangle has to come from the highest point down to the base, and it has to be what? Remember? Perpendicular. Or, in other words, it has to form a right angle. Well, guys, the same thing is true with parallelograms. So, this number here is not the height. Back here, this number right here is not the height, okay? The height is a line from the top of the parallelogram down to the opposite side, the base, so that it forms a right angle, okay? Like that. So, if the parallelogram was turned this way, like this here, then this side here would be your what? Your base. And this length right here would be your height, okay? Now, guys, hold on a second. If the parallelogram was turned like this, okay, no big deal, then this length right here would be your base, and then your height would be the distance outside the parallelogram going from the highest point down to this point here in such a way that if you were to extend this side right here, it would hit right here and form a right angle. Okay, so not that hard. So base, height. Okay? All right, now let's talk about trapezoids for a second. Oh, one more thing, guys. Sorry. Listen to this. The opposite sides of parallelograms are not only parallel, they are also congruent. So please don't forget that. Now, congruent just means they are equal. Okay, so if I told you this is a parallelogram here, and it is, and this length here is 15, then you know automatically that this length right here is also going to be 15. Okay? And if I told you this length right here is 5, then you know automatically that this length over here is also going to be 5. Okay? So, opposite sides of parallelograms are not only parallel, they are also congruent. Alright, now let's move on to trapezoids, okay? Now, if you want to copy this in notes, I think you should, so that you can take some notes off to the side, but there is a trapezoid. Now, let's write some things down about this you need to know. First of all, notice that a trapezoid is always going to have 4 sides, so it is going to be a quadrilateral. All right. And also notice this. This is so important, guys. It only has one set of parallel sides. Okay. It only has one set. If you look, guys, this side here and this side here, they are not running the same direction. This one's going up and down, this one's slanted, and if you were to extend these sides and make them longer, eventually they would hit each other, okay? But notice these sides here are parallel, okay? So in order to have a trapezoid, you must have how many sides? 4 sides, but only one set of sides can be parallel. If now think about it for a second, guys. If both sets of sides were parallel, then you would have what? You would have a parallelogram just like this figure right here. Okay, so trapezoid, 4 sides, only one set of parallel sides. Okay, now let's learn some more information about a trapezoid. This next sentence is really important. It's really huge, so please write this down, and here it is. The bases of a trapezoid are always the parallel sides. So guys, let me tell you what, please copy that in your notes, guys. No, let me tell you what that means. All right, in a parallelogram, I told you guys, it doesn't matter which way it's turned, whatever side is the bottom side, that's going to be your what? Your base. Okay, not true with a trapezoid. A trapezoid does not have one base. A trapezoid has two bases. You might want to make note of that. And they are always the parallel sides. So I don't care which way you grab this thing right here and turn it, it doesn't matter. These two sides right here, the parallel sides, will still be your bases. So on a test or quiz, if I try to, not necessarily trick you, but to make you think a little bit, don't become confused. It doesn't matter which direction I turn, the figure does not matter. The bases are going to be the parallel sides, okay? So, for example, right now, where are my two parallel sides? Here and here. So those two sides are my what? My bases. Now, if I turn this trapezoid so that it looks like this right here is not your base because it's not one of your parallel sides. I mean, look, guys, come on. Is this side here parallel to this side here? Are they running the same direction? No. One's going horizontally and one's slanted like this. No, they're not parallel. So this side here and this side here cannot be your basis. Can't be. So your basis would be this side here and this side here, even though this parallel or this trapezoid is going up and down, these two sides here are your bases. Okay? Now, let's talk about the height of a trapezoid. Okay? So here we go. Now, the height is a line that always, guys, are you listening? The height of a trapezoid always, you might want to write this down, connects the bases and is perpendicular to the bases. Okay, now when I say connects, there could be some exceptions where, remember, sometimes we'll draw the height of a triangle on the outside of a triangle like that. Well, that could happen with the trapezoid where the height is drawn outside of the trapezoid. Okay, but for now, I'm just telling you the height connects the bases and is perpendicular. So to be honest with you guys, this line right here, because there's a right angle here, this line here is the height. But there's more than one height, and all the heights of this trapezoid have the same length. For example, look, this is also the height. I mean, think about it, guys. It connects the base here to this base here, and it's perpendicular. Or you could say the height is right here, as long as it connects your two bases and has a right angle. Because, guys, you're smart students, you understand this. I mean, is not this length here the same length as this length here, which is the same as this length here? Sure it is. So any of those can be your height, okay? It's just length that connects the two bases and is perpendicular. Now, guys, that's a symbol right there you'll learn later. This symbol here means perpendicular. Okay, so it has to connect the two bases and it has to be perpendicular to the bases. All right, so with that in mind, let's get after this. Let's look at two problems and we're finished. Okay, not too bad. Okay, guys, in order to find the area of a parallelogram, you have to multiply the base times the height. Okay, the base times the height. So if I were you, I would copy that formula into your notes. Now, students, here we go. Okay, so in your notes, if I were you, I would copy down this parallelogram here. And now let's find the area of this parallelogram, okay? So we have area of a parallelogram is what? Base times the height. So my base is going to be what? X. And my height is going to be what? 5. Okay? Now, if you did that, guys, that's wrong. Okay? Remember, we just talked about that a couple minutes ago. The height of a, and hopefully none of you thought that was right. Hopefully all of you caught that mistake, okay? But the height of a parallelogram has to be a line drawn from the base of one parallel side to another parallel side from the top down to the base so that it is perpendicular. Okay, that's the height. So with that in mind, remember guys, here's what we talked about. Remember, I showed you this earlier in your notes. This is the height here, not that line there. This is the height right here, not this line here. Okay, it has to be a perpendicular line. So there. Now in your notes, go ahead and put this dotted line here, label it with a length of 4, okay? And now we have our height. So let's go ahead and find the area. It should be pretty simple. Area of a parallelogram is simply base times the height. Very simple. So for the base, for the B, I'm going to put 6. And for the height, I'm going to put 4. Multiply them together and you will get 24 units squared. Okay? Not too difficult. Now, let's move on and let's look at a problem, guys, in which we're finding the area. Oh, you know what? Hold on. Let me take a second and show you where this formula comes from. Okay? Just sit back, watch. You're not responsible for this. You do not have to take notes on this, but just watch. I'll be really, really brief. Okay? Watch where this formula comes from. Okay? So, let me draw a parallelogram real quick here. Okay? There. Now, pretend I drew a line here, okay, and then here, and then here, okay, and pretend I took a knife and I cut off the edge of this parallelogram, and I cut it off and I put it over here, okay. So if I did that correctly, which I did, then now that means that this triangle is gone. I cut it off. Okay, it's gone. So let's get rid of it here real quick. It's gone. Here we go. And there we go. Okay, so look what I did, guys. And some of you will understand this, some of you will not, and that's fine. I'm not going to test you on this. You're not responsible for it. And my drawing is not perfect. But, guys, I had a parallelogram, right? I mean, this came right here. This came from over here. And now it's over here, okay? So think about it, guys. Here's my base. Here's my height. That's why you take base times height. A parallelogram is just like a rectangle, only it's been kind of stepped on, like someone came down with a big foot right here and stepped on the parallelogram and squished it this way like that, and so it kind of scrunched over like this. But a parallelogram, is the same thing as a rectangle as in terms of its area. So we just take base, this length here, times the height. And it's the same thing. Now, if you understand that, fine. If you don't, fine. But that's where we get the formula for a parallelogram. Okay? Now, moving on. Let's look at a problem in which we find the area of a trapezoid. All right? So, in order to find the area of a trapezoid, we have to take 1/2 times the height, and then look, we add the two bases together. And notice, students, these two bases here being added together are inside of a parentheses, so you have to do that first. Okay, so the first thing you want to do is add the two bases together, and then take that number there, multiply it times the height, multiply it times 1/2, and we're good. Okay, so that is how you find the area of a trapezoid. Alright, so please copy this trapezoid in your notes, and let's find the area of this trapezoid. Okay, so here we go. First of all, if I'm going too fast, guys, you know what to do. Just pause the video and then restart it once you're caught up. Okay, so guys, here's our formula. Okay, now, first of all, I think the first thing we should do is start with the bases. Okay, do you remember what I taught you earlier? I had you write this sentence in your notes. What it was? It's right here. The bases of a trapezoid are always the parallel sides, and you're always going to have how many bases in a trapezoid? 2 bases. Alright, so with that in mind, my two parallel sides, and hopefully you can look at this and tell this side here is parallel to this side here. So these two sides are my two what? Bases. Okay, so here I'm going to put a 6, and here I'm going to put an 8. Or to be honest with you, you can put the 8 here and the 6 here. Guys, it really doesn't matter. This 1 just means base 1. This 2 is, they're called subscripts. B subscript 1 just means base number 1. B subscript 2 just means base number 2. It doesn't matter which one you put where. It's not a big deal. But there we go. We get 8 plus 6. Now, quickly, let's go ahead and add these two together here, my two bases, and I get 14. That's really easy, guys, okay? Now, the height is either going to be this or this. Well, do you remember what I taught you? It has to be a length that connects the two bases. And so far, they both do that. This length here connects both bases, and this length here connects both bases. But it also has to be perpendicular to the bases. And this side here is not perpendicular. It's not. So notice this length here is perpendicular. So this is my height. And so it goes right here for the 4. Okay? So now let's bring all this up here. Let's do a little work. Okay? So I have 1/2 times. I put 4 over 1 times 14 over 1. Now guys, look, if you want to cancel the 2 into 4, that's totally fine. You'll get the exact same answer. For me, whenever I can reduce or shrink down the bigger number, that's what I like to do. So for me, I'm going to cancel the 2 and the 14. Okay, that's just me. So 2 goes into 2 once, 2 goes into 14 7 times, and now I'm going to multiply. 1 times 4 times 7 is 28, and 1 times 1 times 1 is 1. Okay, so 28 over 1 is 28 square units, and that's it, guys. Now, there's going to be some more difficult problems than this on your homework tomorrow, but I'm just teaching the basics today, and then we'll work on your homework tomorrow, and I'll help you with it as we go along. Okay. Now, guys, I want to stop the video, end up by showing you how we get the formula for the area of a trapezoid. Okay. So some of you understand this, some of you won't, which is fine. But watch this, guys. If I take this trapezoid here, and by the way, how do I know it's a trapezoid? Well, let's see. First of all, it has how many sides? 4. And then how many sets sides do I have? I have one set or one pair of parallel sides. So yes, it is a trapezoid, okay? So let me sketch over this trapezoid here. Now, so pretend I cut out an exact replica of this trapezoid, okay? And then I flipped it and I put it right here. If you'll notice, you now have, and my drawing's not perfect, but you have a rectangle, right? So think about it. When I added my two bases, think about it. This length here is the same thing as this length here, right? So when I added my two bases together, height times base plus base, okay? When I add my two bases together, that gives me this entire length here. And then my height is this here. So when you take height times base, you're really taking this times this. That's the same thing as a rectangle. And then remember, guys, when you multiply by 1/2, you're basically cutting something in half. And does that make sense? Because guys, look, the trapezoid is really half a rectangle. Here's the trapezoid. And remember, guys, I traced over it and I flipped it and I put it right here, and it gave me a rectangle. So a trapezoid is always half of a what? Rectangle. And that's why we take height times the bases, add together, and then times 1/2. Now, guys, some of you will understand that, some of you will not, which is totally fine, okay? Either way is fine, but I wanted to show you where that came from, okay? Guys, I hope this video has been helpful to you all. If you have any questions at all, please don't hesitate to contact